In this video, we're going to look at how we can draw linear and quadratic graphs. When plotting a straight line graph, and the general equation for a straight line graph is y equals mx plus c, you can use a number of methods. So you can look at the intercept, plot the intercept first, and then draw the gradient from that. Or you can use a table of values, or you can put, and what this means, put x equal to 0 and see what the corresponding y value is, and put y equal to 0 and see what the corresponding x value is. So it's depending on the type of graph and the type of equation, and a bit of experience really will show you this. When you're plotting a quadratic graph, so the general equation for a quadratic curve is y equals ax squared plus bx plus c, you should always use a table of values. Okay, so we're going to look just at how we do this. We're going to look at a couple of examples. So the first example says plot the graphs off, and we've got y is equal to 2x minus 1. Okay, this is probably a nice one to use our gradient and intercept method. So this thing clearly has a gradient of 2 and an intercept of minus 1. So we're going to look at that. So I'm just going to plot a few points here. I'm going to plot 1, 2, 3 on my vertical, and then minus 1, minus 2, minus 3 still on my vertical axis, and then I'll just do 1, 2, 3 on my horizontal, and again minus 1, minus 2, minus 3 on my horizontal. So how we can use our intercept gradient method. First of all, you plot your intercept. So your intercept was minus 1. So it crosses a y-axis here. So I've just put this circle at minus 1, and it has a gradient of 2. So how do you do a gradient of 2? A gradient of 2 means as you go across 1, you go up 2. That's what a gradient of 2 means. So as I go across 1 unit, I'll just use the wee pointer here to show you. Go across 1 unit, that's 1 unit. And then up 2, I will go up to here. So that's where I have to plot my second point. So at this point, 1, 1. You then use your ruler, which is going to be awkward for me to do on this. So forgive me if it's not perfect. Not too bad. Not great. Oh dear. No, it's not great at all. There we go. Not great, but you can see the idea. So you can see that's your line y is equal to 2x minus 1. The other method we could do is putting x equal to 0, y equal to 0, just to see that it has worked. So if we put x equal to 0, so you put x equal to 0 and see what your corresponding y value is. So 2 times 0 is 0, minus 1 gives you minus 1. And sure enough, when x equals 0, y is equal to minus 1. And the other thing we could do then is put y equal to 0. And when you put y equal to 0, you're going to have, to get this one in, that's going to be 0 is equal to 2x minus 1, which means 1 is equal to 2x, which means a half is equal to x. So when y was equal to 0, x was equal to a half. And sure enough, you can see here, when y equals 0, x is equal to a half. So there's two methods really used in this example. Okay, we're going to use the method of putting x equals 0, y equals 0 again in this one. So I'm going to put x equals 0. So the y value is going to be 3 times 0 plus 2, so it's just going to be 2. Put y equal to 0 and see what my x value is. So that means 0 is equal to 3x plus 2, which means minus 2 is equal to 3x. So minus 2 over 3 is equal to x. And then we go from here. So, just tidy up, that's a bit of a mess. So that's what we've got. So you've got your x values are 0 and minus 2/3, and your y values are 0 and 2, then, which we need to fit onto this. So just to make life easier, to be able to plot this 2/3 well, I'm going to make every unit 3 wee squares. So there's 1, there's 2. So you can see it's divided into thirds, so it makes life very easy when I'm going to be drawing my minus 2/3. So that'll be minus 1, that will be minus 2, that will be 1, and that will be 2, and down here it'll be minus 1 and minus 2. So 0, 2 is here. It's my first point, x is equal to 0, y is equal to 2. And then minus 2/3, 0 is going to be here. So I've got those 2 points drawn. And then we can just link those up with a straight line as best as we can. And you can see very rough line for mine, unfortunately. But that was y is equal to, and it was 3x plus 2. Now we could have drawn a very different looking graph. We could have done different scale. So very quick sketch of what this could have looked like. If you'd use a different scale, I could have just done my 2 and then done my gradient method. So it goes up across 1 and up 3 because the gradient was 3. And then you could have drawn it that way. So that point would have had to be in what, 5? So would have been what that point was. So you could have had a very different looking graph if you'd done a different scale, but I've gone for the scale. It hasn't specified in the question what scale to use. Okay, this one, and this is one of the ones where definitely using your x equals 0, y equals 0 method is easiest, but I'm going to show you another couple of ways that people will do this one as well. So one like this, I would say, how I would set one like this out, apologies, how I want to set one like this out, I would say put x equals 0, and then I would say then it's 2y plus 0 is equal to 12, which means y is equal to 6, which gives me the point 0, 6. I'd also say put y equal to 0, and then that means you're left with 3x equals 12, which means x is equal to 4. So that gives you the point 4, 0. We can then go on and draw our graph. So y value is 6, so 1, 2, 3, 4, 5, 6. So 6, 5, 4, 3, 2. I'll zoom in here so I can actually see this. 1. And then here, that's going to be 1, 2, 3, 4, go 5 and 6. And then we'll mark these on the other ones as well. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Over here it's minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. So it goes through, I forgot what the points were, I'll write those down again. It went through 0, 6, and it went through 4, 0. So we just link those up. So 0, 6 is here, 4, 0 is here, and link those up using your ruler as best as you can. Bear with me. And that is you. Okay, and that was your line. 2y plus 3x is equal to 12. Okay, again, this is why another one I'm going to be putting y equal to 0 and x equal to 0. So these ones typically are the best ones for this. So ones where you can see you've got your x and your y on both sides of the equation are typically the ones that are easiest to put x equal to y, x equal to 0, y equal to 0. So you can see you've got your x and y on the same side of the equation. So that's why it's nice to do it that way again. Okay, so first one, I'm just going to say put, set out a wee bit differently, maybe that's in the notes. Put x equal to 0. X equals 0, 6 times 0 is 0. Then you're just left with minus 2y is equal to 4, which means y is equal to 4 divided by minus 2. So y is equal to minus 2. So you've got 0 minus 2 is one of your points. We're also going to say put y equal to 0. And then you're going to have 6x minus 0 is equal to 4, which means 6x is just equal to 4, which means x is equal to 4 over 6. And 4 divided by 6 is 2/3. So you've got this time 2/3, 0. So similar idea to one we had before. I've got 2/3, which is awkward to plot. But if I make 1 unit 3 wee squares, so there's 1, 2, and back away, minus 1, minus 2. And on the vertical, we use the same set here, so we're going to do 1 and same sorry, same number of squares on the vertical as on the horizontal, I should say. So you've got -1 and -2. And then the first point we have to plot was this one up here, was our 0 -2. So we're just going to plot 0 -2, which is here. And next one is 2/3 0. 2/3 0 is going to be here. And then we're going to link those with our ruler as best we can. That's not too bad, a wee bit shaky, but it's the best one I've done so far. So we've got, label your graph, that was 6x minus 2y is equal to 4. Okay, so that's us done on plotting different ways that we can plot linear graphs. This example says we are to plot the graph of y is equal to 2x squared minus 3x plus 1, and that's for -2 is less than or equal to x is less than or equal to 4. Now have a look at what they've done here. They have broken this up to help us, and this would be quite common in an exam for them to set this out for you to fill in this. This is what's called a table of values, and also very common for them to do is they give you the axes. And the reason for that is it makes life much easier, that if the scale's already drawn on it for you, then it's easier for them to mark as well, because everyone will have the same scale, so they're not having to figure out if the scale is correct and so on. So typically it will be given to you. Right, how we fill this in then? So just going to look at a couple of these, and then I'll rub these out, these big bits of working out. How we're going to get this is 2x squared. So what you're putting in your calculator, you're doing 2 brackets -2, because that's your x value is -2, and then squared and hitting equal. And when you do that, you will get 8. Okay, how you get the next one? This means -3 times your x value, which was -2. And when you do -3 times -2, you'll get 6. This next line is a bit strange. It's just +1, which means 1 goes in everywhere along here. So fill those all in. And then the last thing, how you get your y value here is you add up the 3 numbers. So you have 8 plus 6 plus 1, which works out to be 15. Okay, I'm just going to get rid of all the working out that I did there, just so that we're not confused by it for the rest of it. And then I'm going to go through and fill the rest of these in as well. So what I'm putting in my next thing on the top here in my 2x squared row is 2 brackets -1 squared, which is just going to give you 2. Next one is 2 brackets 0 squared, which is going to give you 0. Next one is 2 brackets 1 squared, which is going to give you 2. Next one is 2 brackets 2 squared, which is going to give you 8. Next one is 2 brackets 3 squared, which is going to give you 18. Next one is 2 brackets 4 squared, which would give you 32. Next row, we have our -3x row. So we had 6 for the first one. Next one is -3 times -1, which would be +3, -3 times 0, which is 0. -3 times 1, which is -3, -3 times 2, which is -6, -3 times 3, which is -9, -3 times 4, which is -12. And then we'll have to go through and fill all of these in. So just get rid of that working out. So adding the three rows above, I should say, to get your last y row. And when I do that, I get 6, 1, 0, 3, 10, and 21. Okay, now what we've got to do is plot these, and hopefully this is just about on the screen. So when x is equal to -2, your y value is 15. So when x equals -2, y value is 15. So we'll plot that wee point. When x is equal to -1, your y value is 6. So 6 is going to be here. When x is equal to 0, my y value is 1. When x is equal to 1, my y value is 0. When x is equal to 2, my y value is 3. When x is equal to 3, my y value is 10. And when x is equal to 4, my y value is 21. A couple of things to avoid when you're doing graphs. First thing you want to avoid is doing a straight line between each of these. That is no good at all. So it's meant to be a nice smooth curve. Another thing to avoid, so I'll get rid of those wee second. Another thing to avoid on a graph is if I draw my graph like this, a lot of people, what they do is they give it a flat bottom, so that's no good. So remember, if your curve is going down here, you've got a series of points, you have to use your imagination of how it's going to go. I'm going to have a go at drawing this curve. So a wee trick for drawing curves is as you're drawing to one point, moving from one point to the next, cast your eye onto the next point you're coming to, and that sort of keeps it going quite smoothly. So it's not an exact science, but that's not too bad, you can see, and it's very difficult to draw it on this tablet, I have to say, but it's not easy. So this is one time in an exam where you can use pencil, is when you're drawing curves. And there we have it. Last thing is just label your curve, and that's as good as we can go.